All right, so we are in the process of, this is part 2 of finding the sketch of this polynomial, this rational function, r of x equals x squared minus 3x minus 4 over 2x squared plus 4x. So what we're going to do now is find the points of horizontal asymptote crossing. Okay. And we do that by setting the rational function x squared minus 3x minus 4 over 2x squared plus 4x, set it equal to the c value. And what was the c value? In the previous video, we had y equals c representing the horizontal asymptote. It was y equals 1/2. Let's do cross product equals cross product. We'll get 2x squared plus 4x times 1 equals x squared minus 3x minus 4 times 2. That gives us 2x squared plus 4x equals 2x squared minus 6x minus 8. Let's see if we get that right. Times 4 is 8. Okay. And we'll go ahead and subtract 2x squared from both sides. Then we're going to add 6x to both sides. And that'll give us 10x equals negative 8. So x will be equal to negative 8 over 10, which is 4 over 5. Now, what does that tell us? That tells us that the crossing occurs at the ordered pair when x is equal to negative 4/5, that's 1 1/5, the y-coordinate is equal to this, because remember that was y equals 1/2. 1/2. That is our crossing of the horizontal asymptote. And finally, we're ready to do the sketch, taking all the information and putting it together. So here is our graph. Let's go out 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Let's go up 1, 2, 3, 4, down negative 1, negative 2, negative 3, negative 4. And we had x-intercept at the ordered pair negative 1, 0. So that would be here. We have a crossing, an intercept, and then we have another x-intercept at 4, 0 over here. Okay? So we're crossing the graph at those two places. We have an asymptote. We have a vertical asymptote at x equals 0. It's right on the x-axis, the y-axis. So I'm drawing the dotted line beside the y-axis, but it's actually the y-axis that is the horizontal asymptote. For that reason, we do not have any crossing of the vertical asymptote ever, so we cannot have a y-intercept on this graph. Okay, we also noticed that we had, let's see, those were our vertical asymptotes, our x-intercepts. We did not have any y-intercept, which we established already. And we had a horizontal asymptote at y equals 1/2. Y equals 1/2, well, this is y equal 1. So 1/2 would be between 0 and 1. We'll draw a dotted line through 1/2 on the y-axis. All right. Now, we did have a crossing. Remember the crossing that we had? It was at negative 4/5, so it's almost at negative 4/5, which is almost at negative 1, and then up to 1/2, so it's approximately right here. Okay, now what about the graph? We have another vertical asymptote. Don't forget the vertical asymptote. The other one occurred at x equal negative 2. We had a vertical line going through there. Okay, so you can see these 2 points that have to be crossings. It traps the graph. So we are asymptotic on the x-axis, the y-axis. We pass through these 2 points, and we are asymptotic at this asymptote here. It can't cross it. And then let's see what happens to the right. We have to pass through this point on the x-axis 4, and that traps us as we cross over. Now we can't cross above. We got to cross from down below. That's the only way this is going to work, because then we're going to be asymptotic to the horizontal asymptote. We only cross at this one location. We've already established no others. And then we also have to be asymptotic down here on the negative y-axis as well. We can't get trapped in the corner. All right, so that takes care of all the x values except the x values to the left of -2. And for that, it would probably be good to test a point because we really have no other way of knowing what's going on there. So I'll let you go ahead and choose a point, a value of x that's less than -2, and find the location. You'll find that it's in this region up here, which traps the graph in this fashion. And we are finished.